Let's wait a few seconds before we start. Now let me turn on the recording on the cloud. Okay. All right. Hello, everybody. Let's get started for this week. Um, we are learning ourselves on this assembly programming, Mips assembly programming. Remember always you are learning a language or a variation of the assembly language, which is only supported by these specific processor MIPS. Like every processor has its own set of instructions, and they differ. They differ from each other from conception point of view, their memory address like assumption point of view, memory usage point of view, their register convention, etc., etc. They are very unique to each other. like you cannot just take an assembly program targeted for the MIPS and take it to run it or generate executable for a Pentium processor, for example, or Apple chip, right? You cannot do that. Assembly programs are basically different from each other platform. High level programming, yes, you can port. High level programming, in the sense, let's say if you are writing program in high level languages like C, C++, Java, I consider yet one more level up in the language hierarchies. C, C++, those kind of which you need to compile the source code to generate an executable. There you can take a program and use the compiler, a specific compiler for a target processor to create an executable based on the same program and expect that the program behaves in the same way. Even there are compilers which we call a cross compiler, which is option, especially if any of you have used the GNU compiler. They have this cross compilation option. Let's say you are using an Intel machine and you've written a C++ program, you compile it. You can actually specify a target machine for which it need to generate the code for, machine code for. And you can specify MIPS, you can specify ARM, you can specify x86, like which is like Intel compatible processor or AMD processors. Uh, so essentially, those target uh, processor uh, dictate the compiler at the assembly and executable generation step. So it some it's called a backend process. Once you take the compiler course, you will come to know this. There are two distinct part of it. One is front end process, and another is the backend process. Front end process is more like you parse and analyze the like top high level program, and then create a AST, abstract syntax tree, and then do all the semantic syntactic analysis on top of that. That's the part of the front end of any compiler, and which can be very I would say processor agnostics, means it doesn't care what processor you are targeting. But as soon as you are trying to uh, convert that AST into the targeted machine code, first targeted assembly and the machine code, there you need to be very much specific about which processor you are targeting in compilation process. It varies from one processor to another. So that's the backlog or back monologue, I would say, of the whole discussion. A little bit um, sneak peek into the compiler topics, how what it does and what happening. But let's come back to our topic. We are trying to learn the assembly language for MIPS processor. Okay? Trying to learn assembly language for the MIPS processor. Um, any question before we go into some more detailed discussion around that? While in the meantime, let me check our discussion if there is any new question came up. Oh, there are two comments on module 4. ROL and ROR from Yang Zhang. Jump 16K. There are two, both of them from Yang Zhang. And one is saying that rotating the ROL and ROR, how they are implemented. So I believe you were asking about how the things implemented inside the hardware, right, Yang?
Yes.
Okay, let me try to explain, but yeah, before that, I would like to visit that page and share with everyone that what is that to instruction is. And then can you explain what is meaning of the jump 16 key instruction? Is it from those pages from the appendix, or it's something that I mentioned in the class?
From the second video in the lecture 11, I think, you think like the jump, the range will be, it's not like a 16K bit, it's a 16K instruction. So I was really understand what you mean by 16K instruction.
Oh, okay. Yeah, okay, I'll address them both. Then, okay, let me first go and open up the page where the ROR function is discussed. Okay, let's see. Okay, let's together first review that. Okay, all right, ROR. Somewhere down the line, yes. Q. Oh, rotate right. Rotate right, rotate left, right? So they are already given marked as a pseudo instruction. So that means our life is easier. We can actually try that out in our Mars and see what they do actually. All right, so let's do that. So ROR, some destination source, rotate right, rotate left. Okay. All right. So let me, why don't I just share my Mars screen, share Mars, share. Okay, let's stick in ROR and ROL. Okay, and do assemble. Okay, let's see. So here's the ROL. You see the ROL is actually divided into more basic functionality where it is it is using okay, let me see what they're doing. Okay, so assembler temporary, doing some subtraction, 0 with that, then $2.1 SRLV. So SRLV is the logical SRLV. What is the SRLV? Or shift right arithmetic variable. Okay. Okay. So it's basically that much amount. It is shifting out, and then you are ORing it. Okay. Okay. That's good. So this is broken down into 4 steps, and these 4 steps are something like you are, the main theme is that you want to chunk the part, okay, the part at the LSB side or MSB side, depending on what rotation you are trying to do, and then chunk it back. You make a shift and or back the whole beat pattern, right? So what I mean is something like this. Uh, Share whiteboard. Okay, so let's see if we can have like an example. Okay, so let's have duplicate some 8-bit example. Let's say there are 8 bits, and uh, let's put something like 1. Duplicate. Okay, so let's just put some random uh, bit pattern. Okay, okay. Now we want to do something like this instruction. I want to do an rotate left. Rotate left on this bit pattern by, let's say, rotate left by, that's a 3-bit. Okay. So this function essentially saying that you take this bit pattern and rotate this direction, rotate into this direction, but with respect to the shift, how it differs, instead of filling up the MSB with zeros, it's basically these bits are rotated back onto the pattern. So essentially from this pattern, the target result would be like this. Let's say, how do I do that? Okay. So your original shift, right? Original, let's say duplicate this one. Let's keep it aside. Let's keep it aside. And let's keep it aside. So now just simple shift right logical or value, it basically your bits are going out of the scope and these bits are shifted, let's say by 3 amount. And these 3 remaining bits are filled up with 0. So that's the normal shift right operation. Now on the rotate, instead of going like filling up this MSB side in case of right shifting, instead of doing it basically fills up, oops, delete, with the LSB bit pattern. So remember, like here we kept them separate, these patterns. Okay, this was like bit 0, bit 1, bit 2. So what will happen, this bit will come here, this bit will come here, and this bit will come here. Okay, so that's the operation. That's the operation. Now, how is going to happen? So basically, what we all need to do is take this bit pattern, okay, then construct a bit pattern from this, 8-bit pattern like this. Oops, not this one. 1, 0. Okay. So remember, like normal shift wise, if we do a normal right shift, it would give you this result. And take those LSB 3 bits from that operands, build up a pattern like this, okay, and OR it. Simple, do a logical OR. So if we do OR between this pattern, which is a shift right operation, with this extracted pattern, then my result will become like this, right? This will be OR into place, and this will not change anything, any result, and this will be here, right? And this becomes a rotation result. So exactly that operation being done with those 4 steps that we just shown, I have seen in that Mars window, that it is trying to construct that target bit pattern so that at the end of the day, it will OR between and like a shift right result with that pattern. Is that clear to everybody, to Young?
Yeah, I got it. Thank you.
Right. So yeah, for exact operation, just study those expansion, and I believe you can achieve it by many other ways. Like that is not the only way that you can do it. Okay. So this assembler, Mips assembler took one way to achieve that, but at the end of the day, you can achieve it through many other different ways. The same thing. But target is that build up that bit pattern involving the LSB for in case of ROL, and OR it with the shift right operation result. Same for the oh, by the way, my bad. This was, I was giving an example of ROR. It is a shift right direction from MSB to LSB side. For the ROL, from LSB to MSB side, is the same notion, same operation, but as if these bits are coming into here. While shifting the pattern, these bits are coming into through the LSB side. So that's the rotation of the thing, and it achieves in the same way. Ultimately you will use a shift left logical left operation, and OR with the bit pattern of 0, 0, 0, 0, LSB side you put this pattern, right? I think it's the opposite way, maybe, yeah. But anyway, so you make a pattern, make a logical OR, and that's where you get an ROL operation. Okay, the next one was, what about that 16K, right? 16K, what is meant by that one? So it's essentially something like this. Let's say the question is basically this one. Like if you have some instruction like compare and jump, like a BNE, $S1, $S2 to some level, let's say L1. Okay. The question is, from exactly this point, how much forward you can go at max and how much backward you can go at max. Okay. So this is basically an immediate kind of operation, that where your address is up. This is a PC relative addressing, first of all, right? And where it says, let me change the font, where it basically says is this, your PC next is equal to PC current plus 4 plus some offset. Okay, and that offset can be either positive or negative. Depending on this value being a positive value, you are jumping forward, means towards the higher addresses, and being the negative, offset being negative, you're actually jumping backward to some extent. So that means if we take this offset value as just my immediate field value, then we are actually bound by, my jump is bounded by, this would be like -2 to the power 15, and that is the maximum, that is the minimum offset that we can do on the negative side, and this would be 2 to the power 15 minus 1. This is the maximum value offset we can provide into this formula. Okay. So in terms of the number of instruction, what does it mean? It means that minus 215, yeah. So it means that essentially, if this offset is an address offset, and like -1, -2, -3, if you go up like that or go down in the negative scale, -1, -2, -3, etc., then the farthest you can address with that scope as this address plus 4 minus that many, right? Minus of that many thing. Now, imagine like we are wasting some of the scope of jumping even further, because each instruction is a 4 byte, right? If it is a 1 byte instruction right here, it's like 1 byte address, 2 byte address, 3 byte address, 4 byte address, right? So this entire thing is an instruction in the space, and we don't need to address. We don't need an ability to reach each of this byte address. What we all need is to address this 4 byte altogether. right? So that means in the offset, we don't, if we instead of telling this is an offset of the memory, let's say offset as in the address, instead of doing that, offset of the address, instead of doing it, if we tell this is an offset for the instruction plus offset of the instruction, that means in my actual address calculation, what I need to do is multiply. Okay, sorry, let me put it here. This if we think this immediate value in the machine code is meaning that an offset of the instruction means, okay, jump from here to one instruction up, or two instruction up, or three instruction up, so on and so forth, or one instruction down, two instruction down, three instruction down, then our address calculation would be simply PC plus 4 like this multiplied by 4, because each instruction is a 4 byte, and that means instruction start address from one instruction to other are 4 byte apart from each other, means 4 byte address apart from each other. So essentially this means we are going to address 2 to the power of 15 instruction above this point, or 2 to the power 15 instruction below this point, right? Now, what is 2 to the power 15? 2 to the power 15 is like 2 to the power 15 is basically 2 to the power 10 multiplied by 2 to the power 5. And we all know 2 to the power 10 is 1 kilo, like is a kilo unit in terms of computation. So it's basically then 2 to the power 5 is 16 and 2 to the power 10 is k. So that's where that statement comes in, that for the BNE or test and jump kind of instruction, we can access 16k instruction like above this instruction address, or 16k instruction below this instruction address. So that's where that 16k instruction addressing comes in. So as long as your jump target address is within that 16k instruction amount, in both way, in either way, you are okay. But you cannot jump after that. Is that sounds okay? Yeah.
So which means the 16k instruction range is like how many this instruction occupy the bits for like 16k total?
So this essentially means that how far you can jump from this point, test and jump that instruction point below and above. How many instruction you can go back at max, or you can jump forward at max.
Okay, got it. Thank you.
Okay. All right. Is there any other question? Okay. So we are trying to learn the programming concept using the Mips language. So essentially, for any language study or any language learning, if you want to pick up, you want to basically, there is very basic thumb rule. It is very simple. to learn any new language. Believe me, like the complexity lies in all the library function it provides, all the existing like header files, APIs. Those are the complex things. Those are kind of need to like to know kind of things. But essentially, the programming wise, if you want to write a program from scratch without using any library or APIs or anything like that, it is very, very simple. Every language is very, very simple. There are like 5 things you need to concentrate on to learn on any language if you go into to learn anything. Number 1 would be something like assignment of variable and storage allocation. That would be something very first thing you probably need to pay attention to. So it is something like this. Let me just write it down for you. Number 1, you need to learn how to declare a variable. So variable declaration and storage. Okay, so whether it is an integer type variable, double variable, character type, string type, it's all like how do you declare variable and storage of that. And then next things comes up is your arithmetic and logic operations. How you can manipulate those variables, those storage, arithmetic and logic operations. So you need to know like this language, what are the basic operators and those manipulations kind of things. So those things you need to look for. Then next thing comes is a branching. It is more like a decision making. How do you proceed on this test and execute some part of the code kind of scenario, right? Branching is everywhere in your software program. If you think of high-level programming you are writing, it's always like you declare variable, you do some bunch of operation, then you make some test on some variable values, and based on that testing, you decide to execute a part of code or not, right? So those are the branching and decision making. And next comes is a looping. So you want to like write a block of code and repeatedly execute with some changing variables to achieve some end goal, like implementation of target algorithm and so on and so forth. So looping is another thing to look forward to learn in any language. And then most fundamentally, how to write a procedure or function. Definition and calling the function. Both of them. How do you define a function or procedure and how do you call this? Whether in the object-oriented paradigm, it becomes a method, you call it a method or interface, I don't know, like what you call in Java world, but ultimately they are procedure, okay? Either it is attached to an object or it is independent as in a functional programming paradigm, but ultimately it's a procedure, and the target is always to write some reusable code. Like you make a function, let's say you are writing a function for the factorial computation and use that, call that function whenever it's necessary in the other part of the implementation of the software or whatever you are doing. But it is more like to reuse your code over and over time instead of typing the whole procedural steps, like example, this factorial. Every time you want to use it, you just make a function and reuse that piece of code, calling it with different arguments. So that's the procedure thing. So last lecture, hopefully by this time you know the Mips language, how do you declare variable and storage, and what are the general theme of the arithmetic and logical operation that is being possible with the Mips language. Today's topic was more focusing on the branching and looping. Like how do you make a decision-making code and do looping, write the looping code, etc. And then next lecture is more focused on the procedure and function discussion, like how do you define a procedural function in the Mips paradigm or assembly paradigm, and how do you call it, like from different part of the other part of the assembly code. So that would be the next lecture topic. So today, let's focus on with some example. In the video, I have given some example there as well. Let's almost reiterate that so that every one of us on the same page, and the branching and decision and looping, these two. In fact, if you think, looping is not much different than branching. It is basically you decide to repeat some code, some block of code, some certain amount of time depending on some condition. So it is more like a branching decision kind of fall back into us. So let's take an example. For example, let's say we want to convert a very high level code like this. This is a high level code, okay? So we all know, first of all, how do we want to define the storage and variables? Like in high level language, you have like this variable type declaration. Let's say it is integer, then you give a name, maybe some initialization of value of that variable at the very high level. Now at this low level, what you can do is, you probably already know and familiar with, you start with the .data section and just simply define that label and say it's a word, it's an integer type, it's a word, initialize with 10, B, it's another word, initialize with 20, and C, another word, initialize with 0. Now comes to the programming part of it. It's simply very simple code. It's testing if A is greater than B, and then do something if that's true, otherwise do something else, and then follow through the next instruction. So question is, how do we convert it from here to there? Okay. So essentially, this means we have two blocks of code here in this example. One is like, this is a block of code, and this is another block of code, right? And assembly language, it doesn't have a concept of this grouping of statements in a block, right? It's more like a little bit different mentality and different mindset. I would say a little bit of different paradigm with using some statement called goto. Okay. Goto is a high level construct. Java abandoned this, but C language still actually has that. Not many programmers use it. It is not recommended to use a goto kind of function, but it is available. Okay. So the goto followed by some label, followed by some label name. So that's a high level program construct already. So first intermediate step would be to make this guy into a high level code using goto. Okay. So here what we'll do, this part of the code will simply make some label first. Okay, so let's say we call it label L1. And by the way, this is a valid C syntax as far as I remember. And then from here, we change this code with the goto. Okay, so we say something like this: if A less than B, sorry, less than equals B. So we basically give the exact opposite logic onto that if statement. Go to L1. That's end of the statement. Make this next statement, make this go to L2, another statement, abandon your else, and that's your program basically. Okay, so this is an equivalent high level code. That's this code is equivalent to this high level code. Just instead of we abandon the block concept and we make a kind of a mentally logical block based on separation through goto. So here it says if A less than B less than equals B, then jump to this guy. So that means it's the else condition. It was a positive was if condition. We make it a else condition true and jump there and follow through. Otherwise means if A greater than B, then come here because this won't be, this condition will be false, this statement won't be executed. So it will come here and execute, and then from here jump there. So you skip the else block at this point. So that's what we do first. Then it becomes an one-to-one match with your Mips assembly language. How it is? So let's do it. All right, first we do this guy. This guy, we have BLE, though it is a pseudo instruction, but it's an instruction nonetheless. We'll do something about this one, okay? Now, before we go with the BLE and do something, what we need to do, BLE is a registered bound instruction, all right? So what we do here is basically assign some registers, okay? Assign some registers to each of these variable. Let's say we want to load this guy to temporary 0, B, we want to load it onto temporary 1, and let's say C will be on temporary 2, right? Now, so that means at the very beginning, what we need to do is first load them. Load word $T0 from A, right? A is a label, remember? Similarly, it becomes like load word $T1 B and load word $T2 C. So we load from the memory those values. Now, the very first one will be do BLE branch on less than equal between $T0, $T1 to L1. Then it comes to this part, C equals A plus B, which essentially means so we are doing now this part. So this one is this. Now we are trying to do this guy. Add 2 0 T1. Okay, and this is still register bound, so we need to store it back onto the variable C, the store word $T2 to C. So these two parts essentially become your, these two statement becomes this. And then from here, then we do this statement, go to L2, which is directly mapped into jump, J L2. Okay, so that's your this statement. Now from here, it's L1. So we are trying to do this guy, else part. L1, it will be a subtraction sub $T2, $T0, $T1, store word $T2 into C. So essentially, this becomes these two. And then we are trying to convert this guy, which will become L2 mol. I think this is a pseudo instruction. I'm just using it. B is $T1, A into B, $T0, $T1, forward $T1 to B. So this essentially become your this statement. So you see, the main idea is to convert your blocked code using a high-level block into code using the statement goto. So that's the concept you need to pick up. And once you convert that high-level program like this, then it's pretty much one-on-one mapping of statement to statement. Okay. Question. No question? Then let's take 5-minute break and we'll be back about 6:52 is 6:53 is. Okay, let's get back with the pop quiz. Please go to your canvas and find out the pop quiz number 3, and then respond to this poll if you are ready to uh, put the password. Nine of 20, 11 of 20. 13, 14, 15, 5 more, 4 more to go. 3 more to go, 2 more to go. One more to go. Maybe 4 more seconds. I'll distribute the passcode. Let me stop here. And passcode wise, here it go.
Professor, are you there?
Yes, tell me.
Um, if I click submit, there's no way to like re-access the quiz, right?
If you what?
If I click submit, there's no way to like re-access the quiz, right?
No.
Okay, I see. Uh,
What happened?
I'm not exactly sure. I click submit, and I thought it was like a confirmation prompt, and I hit OK, and then at last minute I was afraid that I might have said unanswered question or something like that, but I'm not sure.
Hmm.
Yeah, so I don't know if like it missed the question. I
What's your
thought
name?
I answered all of them. Huh?
What's your name?
Fong Wen.
Wang Wen. Okay. Let me see what happens there. Mm, okay. I can open up the quiz for you one more time, Fong, in case you actually accidentally do that.
Okay.
Uh, but your time is still till 7:10, actually.
Okay, sure. That's fine. Thank you.
Yeah, see if you can access it one more time.
Okay, I got it. Thank you. Professor, does this reset my quiz?
Yeah, what's up?
Oh, okay. Um, right. That's fine, I guess.
Okay, all right. Okay, I think all of you are done almost. Maybe for yeah. So let me look at first the statistics. Let me tell you. So far, average score is very poor, 59%. High score, 100%. Uh, so as a whole class, please make sure you do better on the average score. It might be the case like I believe some of us has missed that quiz. Maybe that's the reason. But anyway. All right, let's get back into our discussion of what we have started. And we covered with this branching and decision making. Now, what about the looping? I was typing in some example there while you were attempting the quiz. So loops are something like this, right? Let's say there are various loops like a for loop, while loop, do while loop. There is repeat until loop. I don't know if you have used it or not, but there is. There can be many other form of loops. But at the end of the day, what they are is basically it's a decision and branch uh, statements, okay, but in a compact form. That's what the loop is. For example, like a for loop, what we can do, if this is a for loop, some variables are initialized, and then based on the index variable I, value from 0 and less than variable a, we keep on repeating this loop and do some action s equal to s plus I, and at the end of the loop we do some another action s equal to s multiplied by a in this example. Now this one we can easily translate it into then while loop. Right? So for loop is nothing but a while loop. So in the while loop, what we simply do instead of compact writing of for some statement, etc., we simply put the condition for the looping till while I less than a, do some action, and inside the action we put this increment of the I, that action, inside the body, I equal to I plus 1, and keep on looping. So that means I's value is increasing, and as long as it is less than a, which is 10 initialized, it keeps on looping in this body, otherwise it will go back here. Now from there we want to go with an if jump or if go to high level construct of the same program. So to do that, what we need to do is, let's say, make a label here at the start of the while, and then end make another label outside the block, while block, and then you simply change this guy if does the opposite logic greater than equals a, then go to L2. And then from there, you replace this one simply with the closing braces, simply with go to L1. So essentially, you write a while loop using a if go to statements. And as soon as you make this guy, you just follow the same philosophy what we did here for the branching and decision making. It's one-on-one mapping with the assembly program construct that you have. This one is more like a pseudo instruction of BGE, branch on greater than equal, then go to L2, otherwise do some statement, some arithmetic add, then some increment add I, and then this guy is jump L1 back, right? So so that's the simplest thing. So as long as you can convert into this type of construct in your high level program from this part, or if the program has a while from this, then you are actually okay to map this into directly into your assembly program. So I would suggest that when you start writing complex programming, keep these steps in mind, because we have not, or we are not used to programming assembly, and you won't be programming in assembly much outside this class, like maybe in very critical situation where you must go into the machine code level and do some optimization. Apart from that fact, probably rest of your life you are not going to do assembly programming. Okay, so think, like when I give you some assignment, programming assignment, think as usual in the high level construct form, like how you want to solve it in a high level programming paradigm. Take functional programming paradigm, not the object oriented paradigm. Take the functional programming paradigm, solve that problem, and then translate those branching, looping, even the arithmetic functions, right? Those basic things like the way I shown you, and then map it to the corresponding assembly program. That way, it will become much easier to handle assembly programming writing than if you try to think in assembly programming way and directly code it, start coding it onto the Mips. So that's my suggestion. You can do it other way, no problem. It's your decision. But I found this way it is much easier, so that every time we can actually map it to our high-level programming concept. Question? All right, then if we don't have any other question, then we'll end for tonight. And we'll see you on Thursday then.